with the structure of the game, how it all flows. And I'm going to open Indigo. Now we've got a loop here, which is the main body of the program, and we've got a very concise do loop at that. Everything's running in functions. We fetch the results. I'm not going to go into full depth about what all of these functions mean here, because the video's 30 minutes long already, as this section is 30 minutes long as it stands at this point, so we need to be moving on. The fetch results needs to come first, and then we enter the dynamic update. We set the cursor to the first pixel on the screen, and we proceed with the update game. So let's commence to the update game function. First, check to see if the control key and the return key has been called. No need to check the return key if the control key isn't pressed. If this key combination is true, the development mode needs to switch between true and false, so we just use the not operator. And when in development mode, as you can see down here, we simply are able to explore the level. Control camera using arrow keys. Move the camera around basically. Otherwise, if we're not in development mode, play the game. If the level is loaded and if the ball has been released, watch the ball. This watch object function will watch the ball at this direction, from this distance, and from that height, stored in the view type. The watch object function works like this. If the object exists, position the camera at the object, rotate it to its default, Y rotate it, turn it to the direction, pass through the direction local parameter, move the camera back by the distance using the minus negative operator, and then we move the camera up to the from height, and finally look at the object by using the point to camera command. Back to the update game function. Where are we? Now, if the object is near the hold position, we will render the game complete. Now in your game you might want to advance to the next level or award a certain amount of points, whatever. In this game we simply just end the game if the ball goes into the hole, and it works by working out the distance from the ball and that hole. And if you look in your project file, you can see that this function simply works out the distance between an object and a position, and if it's near enough by this value, 10 units near, we proceed. In this case we work out the time, the current time minus the time the game started, and we get the score. And again, the get score function you can observe when you download the file. It simply pretty much divides the time by the amount of shots, and at the end we just basically repeat the output of this message: game complete, final score, synchronize, and to end the program, when the space key is pressed, fetch results, stop dynamics, which we need to do, and then press the end the program right there. But that's if the ball is near the hole. Now note, the actual hole, the entity, is deep down within the actual physical hole. So once it's near this object, the ball is deep down in the cylindrical or square hole in the level, which you'll see later. Now, if the ball is not near, proceed with this. This is a score ticker, so every so often update the score, handle the keyboard, handle the mouse, and handle the velocity, which we'll take a look at more closely soon. Here we have our properties displayed of what's going on, what's happening. Not all of these will be displayed in the real game, however we displayed them so that we can just develop effectively. don't know why this is here. Y rotate object, the director, to the shot direction. So our triangle will face the direction of the shot direction, position the director at the ball, move the director below the ball by 2 units. Now, if the ball is still, just output to the screen that the ball has stopped, and change the view direction to the shot direction. So whatever the direction we're going to shoot is the direction we're going to look in. Show the director as well. Otherwise, if the ball is not still, hide the director, and the view direction is free. You can look around at different angles whilst the ball is moving. However, when the ball is still, your looking direction will have to be the same as the shot direction. Now, at the end of this statement, we see that if the ball was not released, create the ball. Now, right click, go to declaration. We see here that create ball will output new ball ID, source ball. In fact, this is incorrect. This is invalid because the source ball is being simply, let's remove this line here actually. No need for this. Moving on, clone the object. Now we could have instanced the object, but I find that the clone method seems to work best in this situation. Clone the source ball, show the ball, position the ball at the position passed through the function parameter, make the sphere, make it heavy, about 50 units heavy, set the material as we created the material earlier, if I remember correctly it's 50% bouncy. Set the angular damping, very important. This affects how quickly the ball comes to a halt, a stop, how soon it will stop as it rolls along the ground. A high value will cause the ball to stop almost immediately. A low value, or even a value of 0, could cause the ball to roll indefinitely. Now, the ball has been created, the variables have been set, so set that ball release bit number 2 of our double integer variable to true, so that the program flow can proceed. Now, to conclude, let's look at how we handle the keyboard, the mouse, and the velocity. Since Dark Dynamics is handling all of our physics, all we need to do is interact with the player. The first means of interaction, we'll look at going to the declaration, handle the keyboard. Number 1, if the return key is pressed, set the ball position to the start position. So this is the reset function. You could use a button or a click button or something, a user interface element to facilitate this, but I've just simply used the return key for demonstration purposes. I've increased the shots by 3 because I know that the lower the shots at the end of the round, the more points you get, but I'm going to punish the player a little bit and increase the shots by 3 if they reset the ball. So do not reset the ball too often if you want to try and get a high score. Now I'm going to have to reset the height and power so the ball isn't affected by any previous variables, and set the velocity of the ball. The linear velocity is the speed, angular velocity is the rolling of the ball. Bring all of that to a halt. Wait for the user to let go of the return key before proceeding. If the level state indicates that the ball is still and the right key is pressed, adjust the direction. We add 5 to the shot direction. Yeah, so but in fact it's not 5, it's 5 divided by this calculation here. The first thing to happen, because of the parenthesis and the multiply sign, first If the shift key is pressed, it is multiplied by 10 and added to 1. So by minimum this will be 1. 5 divided by 1 is 5, and that is added to the shot direction. However, if the shift key is pressed, it's going to be 1 plus 1 shift key, which is 2 times 10. Therefore, it's going to become 5 times 5 divided by 20. Therefore, we're going to be moving the shot direction in smaller increments if the shift key is pressed. Likewise, with the left key, we simply do it in reverse order by using the minus sign instead of the plus sign. If the space key is pressed, strike the ball. Whilst the space key is held down, we increase the shot power, and we indicate how powerful the shot is going to be by simply using the pad right and pad left feature of the Matrix 1 Utilities plugin. We keep adding a character to indicate almost like a progress bar as to how powerful the shot's going to be, but obviously you would use the box statement or any progress bar widget or gadget that you use, BBB, GUI or something, but I've simply used text to display the power because I need this to be just coded as fast as possible. Increase the number of shots and add the force. Now I've cheated here because I'm adding so much power to the shot, 10,000 units of power. By the minute we're going to limit it to 1 million. I've looped here from 1 to 100 and I've added the force to the ball. So 100 times this value will be added to the ball to produce the power of the shot. Now I've just cheated here. I could have made this number higher, but I just simply prefer to apply a small amount each time, not as fast, but fast enough for our purpose. This is only a one-shot event, so there's no need to worry about slowing down the performance. And then after that's done, we don't need to have this shot height and power anymore, so we set it to 0. After that, the ball will move. Now, if the board is not still, the only thing I want the player to be able to do with the keyboard is rotate the angle with the left and right key, as per a similar calculation used to rotate the shot angle above.